In this video, we're going to learn to do direct, inverse, and joint variation problems. Let's start by defining some of these terms. So in direct variation, equations are in the form y equals kx to the n, and as x increases, y also increases. Now down here we have three formulas that are all direct variations, and the formula should somewhat look familiar. For instance, this one is the area of a circle. You'll notice that we said they're all in the form y equals kx to the n. K is a number, and in this case our k is pi. K is what's often called the constant of proportionality. Sometimes it's also called the constant of variation. Same thing. All right, so in this particular case, our constant is pi, but we would say that A, which is our area, varies directly with the radius squared. In the next one, we have an equation that says that c equals 1.07x. For instance, this could be the cost after 7% sales tax. So here, our constant of proportionality k is 1.07. And here we could say cost varies directly with the price x. So if something costs X dollars, you're going to pay X times 1.07. That'll be your final cost. And this third one should look familiar as the volume of a cube. Here too we have a value for K. It's kind of invisible, but here K equals 1. And we could say that the volume varies directly with the side length cubed. With the side length cubed. All right, let's move on to inverse variation. In inverse variation, the equations are in this form. Instead of taking k times x to the n, we have k divided by x to the n. And in this situation, as x increases, y decreases. So we have our examples down here. This time they're not real-world examples, but here our k is 300, and we could say in this situation that t varies inversely with r. We know this because r is in the denominator. And then over here, in this one, we can see that k equals 10, and here we would say that y varies inversely with x squared. Our next type of variation is joint variation, and joint variation is direct variation with more than one input variable. And so in this case we have two inputs, both radius and height, and this is our k, our constant of proportionality. This is actually the volume of a cylinder. So we would say in a cylinder, volume varies jointly with the radius squared and the height. All right, so we're going to write some formulas using these sentences. So let's start with this first one. Y varies jointly with W and M. These are both going to be directly, so they're going to both be in the numerator. So we write Y. We always write K next. Jointly with W and M, we've written our equation. Let's try our next one. T varies directly. We need a k, always need a k, and it's directly with the square of a, so a squared is here, and inversely with c, which means c goes in the denominator because of the word inversely. Let's try number 3. H varies directly with the square root of c and inversely with the cube of v. So we have h equals, we always need k, directly with the square root of c, inversely with the cube of v. So v cubed goes in the denominator. Now our homework problems are going to have a lot of word problems, and we're going to have these steps. Our first step is to write the general formula, and we have to make sure we don't forget k. That's what we did on the previous slide. Our next step is to solve for k by substituting the first set of complete values. Once we know k, we can then solve for the answer by using k and the next set of numbers. Let's try an example. Here we're told that z is inversely proportional to the third power of t. Let's get that first step done. So z equals k over t cubed. T cubed is in the denominator because it's inversely proportional. K is always in the numerator. Step 1 is done. For step 2, we take this next set of numbers. So we know that t is 5, so we'll get that there. Here's k equals, and z is 0.08. So we just plug in all the numbers. And now we're going to solve. So see, I'm going to multiply by 5 cubes. So over here on my calculator, I can just type in 0.08 times 5 to the third. And I have my k value. K is 10. And I have my second step done. I know k. My third step is to answer the question, which says find z when t equals 2. So I'm going to put a 2 down here, and I know k. K is 10. It's a constant, so once I find it, it's the same for all the problems. And so now I can go over here and say 10 divided by 2 to the third. And here's my answer. Z equals 1.25. All right, let's try another one. This one involves a few more variables, but it's the same process. So we start by writing the formula. So we're told m varies jointly with n and the square of p. So let's get that part. M equals k n p squared. Remember, jointly is both directly, and inversely with q. So q goes down here. I have the first step done. In the second step, I'm going to plug in these numbers. So m is 20, n is 5, p is 6 squared, and q is 18. All right, I'm going to go ahead and multiply this 5 times 6 squared. So 5 times 6 squared, that's going to give me 180. And I'm also going to multiply by 18. So I've got 20 times 18 here equals 180k. And I divide, let's see, so I've got 20 times 18. And then I'm going to divide that by 180. And k is 2. There we go, that's nice. So now I'm ready to do the third step. And I'm going to find m. So m equals, I'm going to plug in all the values. I know k is 2. I'm going to use this next set of values here. N is 7, p is 11, and q is 2. Oh look, those 2's are going to just cancel right there. That's nice. So now I just need to do 7 times 11 squared, and my answer is 847. All right, let's try another one. Now this next one is in an actual situation. So let's read through it. The illumination produced by a light source varies inversely with the square of the distance from the source. And then we're told, let's see, the illumination at 5 meters is 70 candela, and we're supposed to find the illumination 12 meters from the source. All right, so what's going on? We have this thing called illumination. I'm going to just let that be a capital I. Varies inversely with the square of the distance. I'm going to use d. So if I just break this down, I basically have illumination varies inversely with the square of the distance. So I equals k over d squared. All right, so I got my first step. And now I can plug in these numbers. So 5 meters, that's my distance. So that's 5 squared. And it says the illumination is 70 candela. So I put in 70. So let's see, I'm going to multiply by 5 squared. So 5 squared is 25, so I can do 70 times 25. And I get that my K value is 1,750. Okay, and now it tells me to approximate the illumination 12 meters from the source. So I equals, I know K is 1750, and I put that over my distance squared. My distance now is 12. 12 squared. So here I have 1750 divided by 12 squared. And I get this number. And we're just going to round this to 2 places. So 12.15. And the illumination had this unit's called candelas. So I'm going to just say 12.5 candelas. There we go. All right, let's try another one. All right, a lot of words here, but let's just read through it and see what we can pick up. So the force needed to keep a car from skidding on a curve varies inversely with the radius of the curve and jointly with the weight of the car and the square of the speed. Let's try and highlight all the pieces that are involved. So first we have force, and let's see, it's inversely with the radius, jointly with the weight, and the square of the speed. Okay, it's going to help me to have some letters for these. So let's pick some letters that make sense. So here for force, I'm going to use F. That makes sense. Oh, radius, definitely an R. Weight, W makes sense. And speed, S. All right, so here we go. Let's write our formula. F equals, I've got a K. It was inversely with the radius. That means the radius goes on the bottom. Then jointly with the weight, that means that goes on top, and the square of the speed, S squared. All right, we've got our formula. Now we're ready for the next sentence. It takes 3,000 pounds of force. So 3,000 goes in for force, which is F. I'm going to have to find K. Say 2,000 pound car, that's going to be my weight. From skidding on a curve of radius 500, radius was on the bottom here, so that's 500 goes down here, at 30 miles an hour. So the speed squared, 30 miles an hour squared. Okay, so then let's start figuring this out. So I'm going to take the 3,000 times 500, so I get rid of the fraction. So 3,000 times 500, and that's going to give me, let's see, it looks like 1, 2, 3, 4, 5 zeros. So here we go. 1, 5, 1, 2, 3, 4, 5 zeros equals K times, and I've got 2,000 times 30 squared. All right, and that's an 18 with also 5 zeros. And so when I divide that out, I really can just do 15 divided by 18 is the same thing, because all those zeros are going to cancel. And I get 0.833. So when you get a decimal, if you take it to 3 places, I think you'll be fine. So we got our K, or we could have written it exactly, but we'll go with this right now. All right, so now I have to finish the question. So now it asks me what force, so I'm finding force, is needed to keep the same car, so it's going to be the same K as well, 0.833, from skidding on a curve of radius 800. So my radius is on the bottom, that's 800. 60 miles an hour is the speed. Wait a second, what's the weight? Oh, it was the same car, so of course the weight's going to still be 2,000. So we're going to plug in 2,000 again. So we have the same car, so the same weight. We're going 60 miles an hour, and our radius is 800. So let's give this a go over here. 0.833 times 2,000. And we take that times 60 squared. And then we're going to divide that by 800. And there's our answer, 7,497. And when we're measuring force, that's in pounds. So 7,497 pounds of force. I have a funny feeling though, I want to go back here. If I had not rounded this, 15 divided by 18, let's just try the second entry. I think we might actually have a nicer answer. So let's go back here. Oops. Just want to change this to 15. Oops. Oh, it's still trying to go back. 15 divided by 1. That's the second insert, 18. So I'm just going to try it with the exact value for K. Yeah, and actually the real answer, if I had not rounded, would have been 7,500 pounds. All right, with all of that, you have enough to start working on homework number 2 on section 4.3.